All right. We are going to talk about finding the domain of a composite function. And to be honest, this is the trickiest part of composite functions. Okay, so you can watch this a few times if you need, take it slow. So if we have two functions, f composed with g of x, and we've got f of x is 5 over x minus 1, and g of x is 4 over x minus 3. Let's just think for each of these functions, what are their domains? Well, f of x, we can't have x equal 1, right? X cannot equal 1 for f of x because that would be dividing by 0, right? And g of x, the domain, we can't have x equal 2/3, right? Because that would make the denominator equal to 0. So x cannot equal 2/3. Okay, those are the restrictions on the domains for each of these individual functions. But now we need to think about the composition. So we have f composed with g of x, which is f of g of x. So first, let's just think about this internal function, g of x. What inputs can we not have for g of x? Well, we just answered that. X cannot equal 2/3. So that is one of our restrictions on our domain for our composite function. Right? If we put 2/3 in for g of x, for x, we're going to get something undefined. Right? So that is a restriction on our domain. Now here's the tricky part. What about 1, for example? If we put 1 in for x, what are we going to get out for g of x? I don't know, let's see. It's going to end up being 4. And is that a problem? No. What is a problem? The problem is if the output of g of x equals 1, because that's going to become the input for f. So we need to know, g of x cannot equal 1. Well, what inputs is that a problem for? So we need to solve this. We need to figure out what inputs for g of x are going to give us 1 and exclude those. So let's solve this equation. Let's see, we can multiply both sides. We get 4 equals 3x minus 2. Add 2 to both sides. Divide by 3. And we get x equals 2. So if x equals 2, what's going to happen? If we put 2 into g of x, what will we get? 4 over 6 minus 2. That's going to give us 2. Sorry, 4, right? And 4 over 4 is 1. So the output for this function is going to be 1, and we'll put that in for f. No, it's a problem, right? That is restricted. So we know that x cannot equal 2, which is a little bit surprising because 2 didn't show up here. We can plug 2 into g of x, we can plug 2 into f of x, no problem. But if we plug 2 into f composed with g, we get something undefined. Okay? So sometimes you're going to get new numbers here that you have to exclude from the domain. Okay? So these are good places to start. You find the individual restrictions on the domains of the two functions, but then you have to think how they interact with each other. And you have to say, okay, what values of x are going to give me an output for the internal function that are not allowed as inputs for the external function, okay, or the outside function. Okay, so there's two times we need to be careful of domains, right? One is for rational functions like this, we can't divide by 0. The second is if we're using like square root signs, right? We can't take the square root of negative numbers. So let's look at one of those. Let's see. There we go. All right, we've got a composite function, and f of x, one of our functions is square root of x plus 2, and the other one is square root of 3 minus x. All right, so let's do what we did before. For f of x, we need x plus 2 to be greater than or equal to 0, right? Because we can't take the square root of a negative number. We're just dealing with real numbers. So that gives us x has to be greater than or equal to negative 2. How about over here? For g of x, we need 3 minus x to be greater than or equal to 0. So 3 has to be greater than or equal to x. I'm going to write it the other way because it makes more sense to me. X has to be less than or equal to 3. Okay, so now let's think about our composite function. F composed with g of x is f of g of x. So let's look at our internal function, g of x. This is definitely one of our restrictions. We need x to be less than or equal to 3. Okay? Well, how about the output here? We need the output of this to be greater than or equal to -2. Well, we're kind of in luck because let's look at this function. Are the outputs ever going to be negative? No. The outputs are always going to be positive. The outputs are the square root of 3 minus x. That's always going to be a positive or maybe 0, right? A non-negative number. So our outputs for g of x are always going to satisfy this restriction on the domain for f of x. So we don't get any additional restrictions. We can just, this is automatically satisfied because of the kind of function that g of x is. So for this function, this is the only restriction. X has to be less than or equal to 3. Okay? So this is the trickiest part. If this was a little complicated, you're welcome to watch it again. If it seems tough, that's okay because it is. And you'll have some practice on the homework, and we can talk about it in class if you'd like.